Okay, now let's look at page 2 and continue with polynomials. We're going to divide this trinomial divided by a monomial. So remember, when you are dividing by a monomial, you will get the type of polynomial you begin with. So we will all end with a trinomial. So I'm going to break this down and write each term as its own. And then I have a negative divided by negative, so that's going to be plus 24c to the 6th over 3c to the 3rd, and then a positive divided by a negative is minus. So we have 3c to the 3rd over 3c to the 3rd. We divide here, and we get a positive 3c to the 5th because we use our quotient rule. 24 divided by 3 is 8, and then we have c to the 3rd, and then we have minus 1. So don't cancel this whole thing out. Anything divided by itself is 1. Now we are subtracting, so I'm going to distribute this understood negative 1. So I have 2g squared minus 8g plus 2, distribute the negative. And now we're going to combine our quadratic terms, and we get 1g squared. Our linear terms is minus 16g, and our constant, oh, I forgot the 2 here. Let's add that in. Sorry about that. And so we have 2 plus 1, that gives us 3. And this is a quadratic trinomial. Let's go back to number 11. This is a quintic trinomial. Okay, number 13, we're adding, so we can just dissolve the parentheses and write the terms as they are. When we combine our quadratics, they do cancel out and give us 0. We have negative 1w minus 12. So this is a linear binomial. And now let's get into simplifying some square roots. So we're going to convert all this to as many perfect squares as we can. So we know 4 is perfect. We're going to break down x to the 3rd into x squared times x. And then we have y squared times y squared times y. So I've not changed the value of my radicand. I've just rewritten it. So I have the square root of 4 is 2. The square root of x squared is x. And then I have 1 and 2 perfect square roots of y squared. And then I'm left with a radicand of 6y. Here on 15, we have the understood negative 1 that we must bring down. And 108 can break down into 36 times 3. X to the 4th can break down into x squared times x squared, and then we have y. The square root of 36 is 6 times this negative 1 that's already there. That gives us negative 6. We take the square root of x squared, and we take the square root of another x squared, and then we have radical 3y left. Here we have negative 4 is a coefficient. We're going to break down 80 into 16 times 5. And then we have x squared times x squared times x squared. And we have y squared. We have 4 of those. So everything in our radicand, all these factors are perfect except the 5. I take the square root of 16, which is 4 times the negative 4, so that's negative 16. And then I have 1, 2, 3 x squares. And then I have 1, 2, 3, 4 y squares. And then I have radical 5. 17, we have a fraction as our coefficient that's already there. 72 can break down into, let's see if that'll undo that. Okay, perfect. 72 is going to be 36 times 2. Then we have x, y squared y. We take the square root of 36, which is 6. And then we take the square root of y. Let's undo that, make that a little bit neater as well. And then what's left, so we've taken the square root of those, we have 2xy. And now we're going to multiply 2/3 times 6. So 2 times 6 is 12. 3 times 1 is 3. and we get 4. So just a little reminder of how to multiply fractions times whole number. Okay, now let's add radicals. Remember, this acts sort of like fractions in that our radicand has to be the exact same, and then we just bring it over. So we're going to have 54 is 9 times 6, x squared. 24 is 4 times 6, Lola squared, and then minus square root of 6. So the square root of 9 is 3, the square root of x squared is x, radical 6, plus the square root of 4 is 2, x squared is x, radical 6, and we have minus 1 radical 6. So this is kind of a double doozy. So when we combine like variables, okay, so this is 3x plus 2x, but I do not have an x coefficient, so I'm not going to combine the minus radical 6. So I have 5x radical 6 minus radical 6. So I had a double doozy, as I was saying. Your variables had to be the same, and our radicals had to be the same. So the radicands were the same, but I can't combine 3x with just a minus 1. They're not like terms. So here is our final answer. So here we have 2/5 radical 6x squared times 15 radical 3x. So we're going to multiply 2/5 times 15. So that's going to give us 30 over 5, which is 6. So my coefficient is 6, and then my radicand is going to be 6 times 3 is 18, and x squared times x, using our product rule, is x to the third. We're going to rewrite 18 into 9 times 2, and then x squared times x. The square root of 9 is 3. 3 times 6 is 18. The square root of x squared is x, and we're left with radical 2x. Here we're going to divide coefficients. So 12 divided by 2 is 6. We're going to divide radicands. 24 divided by 3 is 8. X to the third times x to the 1. Quotient rule, x squared. We're going to simplify into 4 times 2. And then we have x squared. Take the square root of 4, which is 2. 2 times 6 is 12. The square root of x squared is x. Radical 2. Okay, on 21, 3 can't go into 8, but we can simplify the x's, and we can divide negative 5 by 2, but we're just going to leave that for right now. So I'm going to say negative 5 over 2, and then we have radical 8x over radical 3. I just simplified the x part. Now we have to rationalize the denominator. And don't worry, guys, my dogs are not fighting. They're just playing. They're just kind of loud. And then I'm going to rationalize, okay, the denominator. And I just need to multiply it by the radical 3. You don't need to bring the 2 with it. So when I multiply this, I get 2 radical 9, creating that perfect square. Here I get negative 5. And then 8x times 3 is 24x. And then I have negative 5. And then let's break apart 24 into 4 times 6. X over the square root of 9 is 3 times 2 is 6. And before we move on, I am going to clean this up a bit right here so we can see what that is. So that was 24x. And then the square root of 4 is 2, and 2 times negative 5 is negative 10. And we're left with radical 6x over 6. And then negative 10 over 6 can simplify by a factor of 2. So I have negative 5 radical 6x over 3. That was a nice problem. Okay, now let's do perimeter. That's adding all sides, and we're doing radicals. So I'm going to go ahead and simplify each of these. So I have 2/3 radical 12m to the second and to the third, plus radical 27 m squared into the third plus 2 radical 12 m squared into the third. So when I break this down, this is going to be 4 times 3 and bring down my 2/3 plus 9 times 3, m squared n plus 4 times 3. So it does look like all of these terms can combine. So the square root of 4 is 2, and 2 times 2/3, so 2/3 times 2 gives us 4 over 3. So we have 4 over 3. We take the square root of m and the square root of n, and we have radical 3n. Plus, I take the square root of 9, which is 3 m n radical 3n. And then square root of 4 is 2 times 2 is 4 m n radical 3n. So we are going to add these up. So we have 4 and 3 is 7, and 7 and this is really 1 and 1/3, that's 8. So perimeter equals 8 and a third mn radical 3n. So let's go with that to make sure. So this is really 1 and 1/3. So I have 1 plus 3 is 4, plus 4 is 8, and then I had that third. Perfect. Okay, now area is base times height divided by 2. So my base and height, so we're going to have 2 radical 12 mn squared into the third times, we have 2/3, and then we have 12 m squared into the third. And then we divide it by 2. So 2 times 2/3, that's going to be 4/3. 12 times 12, 144, m to the fourth into the sixth, all over 2. The square root of 12, I'm so sorry, the square root of 144 is 12. So I'm going to say, so I have 4/3 times 12. This is going to go 3 into 12 is 4, and 4 times 4 is 16. So I have 16 m squared into the third all over 2. So area equals 8 m squared into the third. Wow, what a problem, Miss Thomas. Okay, now let's go over this one. We are going to do perimeter. So we have 3 times 108 m squared into the third. And we have another one of those. And then we have radical 48. So 108 breaks down into 36 times 3. Okay, so this is going to be 6 times 3 is 18. Mn 3n plus another one of those. Square root of 16 is 4. Mn. And one more of those. So I have 18 and 18. So that is going to be, so 18 plus 18 is 36. And I have 4 and 4, that's going to give us 8. So that's going to be 44. So our perimeter is going to be 44 mn radical 3n. Did I think I wrote an m here and we did not need that, so let's erase that. Yeah, we'll just write that a little bit better. Okay, now let's do area. So we're going to have 3. I'm going to go ahead and just use my simplified answers for this. So I'm going to do 18mn radical 3n. I think that will be a little bit easier than multiplying by 108 and 48. So I'm going to take this that's already simplified, and I'm going to multiply it by this radical that's already simplified. So 18 times 4, that's going to be 36. So that's 76. 8 times 4 is 36, yep. So 76 m squared n squared times radical 9n squared makes a perfect square. So now we have the square root of 9, which is 3. So we're going to have 76 times 3, 21, 22. So that's going to be, so area is going to be 228. And then I take the square root of n squared, which is n. So I'll have the m squared and then now n to the third. What a problem. My goodness. And look at this one. So we are going to get the area, which we already did up here, and then the area of the triangle that we already have, and then we're going to subtract them. So we have the area from the rectangle above was, we said 228 m squared into the third minus the area 8m squared into the third. So we have a like variable, so we can subtract, and when we do, we get 220 m squared into the third. So that wasn't so bad because we had already done all the work.